Hello everyone, I am back with today's daily LeetCode challenge problem, and in this question you are given an array of lengths arrlen, and there is a pointer which is initially at index 0. So at each step you can move either one position to the left, one position to the right, or you can plan to stay in the same place. In this question the goal is to find the number of ways you can take exactly steps while still ending up with the pointer at index 0, and then you have to return the result modulo 10 raised to the power n 9 plus 7. Okay, so let's start with the implementation. I'll explain each line of code while writing the code. So first of all, as we can see that there's class declaration, and here we define a class named solution, and then inside this there's a method called numWays, in which you take two numbers or you take two integers, namely steps and array lengths. Okay, now initially what are we going to do? As we have to return the result in modulo 10 raised to the power 9 plus 7, let's initialize a constant value named mod as, okay, 1 2 3 4 5 6 7 8 and 7. Okay, so this is the value that we have initialized. Now we have initialized a constant, and why have we initialized this value? We have initialized it in order to keep our calculations within a certain range, which is important to prevent very large numbers from causing problems. That is, in simple words, we don't want overflow to be caused, and that's the reason we are just setting up a higher valued constant. Okay, let's initialize our maximum position as we are initializing a 2D array named dp. Okay, and so let me explain. First of all, what are we doing? We have initialized or set a constant value which is named mod to a higher value, okay, as given in the question. Then we are here to find the maximum position. So by writing this, we are just figuring out the farthest position we could end up after all these steps. Okay, we are taking either half of the steps, or we are just taking the length of the array minus 1. Why? Because this is a zero indexed array, so the total length, the total number of elements in the array will be array length minus 1. Okay, so whichever is smaller, we are going to take that. This is because if we walk in one direction, for too many steps, we might end up hitting the end of the array. For example, let me try to explain what I'm trying to say. For example, you are given number of steps as 10. Okay, number of steps as 10, and this simply means that you can move 10 steps. Okay, and you are given the length of the array as just 4. So just wonder, if you keep moving to the right side and the length of the array is just 4, the number of steps allowed to you is 10. What do you think? If the length is 4 and you are given 10 steps, do you think just moving towards the right will end up coming back to the index 0? Obviously not. This simply means you will go out of the index bound. So this simply means we cannot exactly take the number of steps given in the question as our maximum position. So in order to take the real number of steps, so that we don't get a value which is out of our index bound, so we have to take the number half of the steps, and then we can take the minimum of these two in order to just end up inside the array. Okay, and then we have initialized this value. We have created grid. Okay, we have created a grid that is with rows and columns, and that's a 2D array named dp. Okay, and here the number of columns is max position plus 1, while the number of rows is steps plus 1. So this is dp 0 0 equal to 1 is nothing but the starting point of our dynamic programming. Okay, this is written in order to show that there's only one way to end up at position 0 or index 0 when we have not taken any steps, which is by just staying at exactly where we are. Okay, that is exactly at index 0. Now we have two nested loops here. I'll explain this as well. We have two nested loops. One is to iterate through all the possible steps, and one is to iterate through the total number of positions. Like starting from the leftmost position, we are going to move towards the maximum position allowed to us. I hope I'm making sense. Let's so yeah, we have started a loop at different scenarios, just iterating through steps and all the positions available. Okay, now if we want to stay in place, if we want to stay in place, if you want to stay in place at the current position, the number of ways is the same as that in the previous step, right? So we can write this condition. For example, if you want to not change your position, what are you going to mean by that statement? We just simply mean that the number of steps that you took, or whatever you did to stay at your previous position, you will have to do exactly the same for your current position. So we can write this. Now if j is greater than 0, what does that mean? When I wrote this for loop, here j just represents the leftmost indexed position. Okay, and if I say j is greater than 0, what does that mean? That simply means that you are not at the leftmost position, that is, you are not at index 0. So what are you going to do? If j is greater than 0, then dp of ij will be equal to dp of ij plus dp of I minus 1 j minus 1 modulo mod. Okay, now so for example, why did I write this? If you are moving towards the left, if it is possible to move towards the left, what does that mean? Means we are not at the very beginning, that is, we are not at index 0 of the array. We are considering how many ways we could end up here from the step before the previous position. Okay, now we can write another condition when j is less than max position. Okay, if j is less than maximum position, then dp of ij can be written as dp of ij plus dp of I minus 1 j plus 1 modulo mod. Okay, and then we can do what? We can just, I think there is some error, so yeah, probably just give me a second. Okay, so yeah, we can now return dp of steps, that is the number of rows you can say, and since you have to return to the initial position, that is your index 0, the number of columns would be 0. So basically, similarly, it's possible to move to the right. That means you are not at the maximum position. We are considering how many ways we could end up from here, from the step before, at the next position. This is the condition that represents that, and this is the end of the loop, and then we are closing the loops, and then that means we are going through all the possible scenarios, returning the result. So basically, we are providing the answer here. This just provides us with the number of ways we can end up at position 0 after exactly steps. Okay, and I hope that this explanation helps you understand the code better. If you have any further questions, feel free to ask in the comment section. Now let's try running the code. Okay, so the code is accepted, and let's try submitting it. Okay guys, thank you so much for watching. Stay tuned.